Hello students, this is a video to explain what perfect squares and square roots are and square roots that are not perfect squares. So what we first have to look at is a multiplication table, and you'll notice that on this multiplication table there are numbers on the diagonals that are highlighted with yellow. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 21, 144. And they go kind of in a perfect diagonal line down. And those are the first 12 perfect squares. So what do perfect squares mean? Perfect squares are the numbers that you get when you multiply a number times itself. So for example, 1 times 1 is 1, which maybe not be the greatest example because I just said 1 3 times. So 1 times 1 equals 1. So 1 is the first perfect square because 1 times 1 times itself equals 1. 4 is the second perfect square because when I take 2 times 2, a number times itself, I get 4. So 4 is also a perfect square. Then we have 9. 9 is a perfect square because 3 times 3 equals 9. A number times itself equals 9. So therefore 9 is a perfect square. And 16 is a perfect square because 4 times 4 equals 16. A number times itself equals 16. And so on and so on. 25 is a perfect square because of 5 times 5. 36 is a perfect square because of 6 times 6. 49 is a perfect square because 7 times 7. And so on and so on and so on until we get to 144, because 144 is a perfect square because of 12 times 12. So what does that mean for square roots? Well, square roots are perfect squares because, as I said, if you take a number and multiply it by itself, you get one of those perfect square numbers. So then if I was going to take a square root of one of those, and a square root symbol, you've probably seen it before, is something that looks like this. It's one of the symbols that looks like this. Kind of looks like a long division symbol, but it's not. So then if I take one of those perfect square numbers, let me just pull 36. So the square root of 36 equals 6. Okay, so all you do is you find the perfect square, and you ask yourself what number multiplied times itself. So in this case, it was 6 times 6. So the perfect square of 36 is 6 times 6. So then what's the perfect square, or the square root of 64? The answer would be 8, because 8 times 8 equals 64. So the square root of 64 is 8. What's the square root of 81? So I look. Square root of 81 is 9 times 9. What's the square root of 100? Square root of 100 is 10, because 10 times 10 equals 100. So that's really easy when you have perfect square roots, because we know now that we just look at what number times itself. But then there are some that are not perfect squares. So for example, if I take the square root of 3, well, there is no number that I can multiply time itself to get 3. So when I take the square root of it, if I use a calculator or if I use a tool online to find the square root of numbers, if I find the square root of 3, I would find that it was 1.7320508 with a repeating 0.8, and that 0.8 would go on and on and on forever. If I took the square root of 11, well, there's no number times itself that equals 11. So the square root of it is 3.1366247.9, on and on and on and on and on. That decimal never ends. It would just go forever. Square root of 22, there's no number multiplied by itself that equals 22. So the square root of it is 4.69041576, on and on and on and on and on. So that's the difference between a perfect square root, like 36, 64, 81, 100, and all of these really, but those are just examples that we looked at, and one that are not perfect squares. And these would be considered irrational numbers because they do not have a perfect square, and they go on and on and on and on and on forever. These would be examples of rational numbers because they give us whole numbers, terminating numbers. Square root of 36 is 6. That number terminates. Square root of 64 is 8. On and on and on. So that's the difference between, again, perfect squares that are rational and square roots that are not perfect squares that would be considered irrational. So hopefully that video helped you. Reference this as many times as you need to watch it.